So yesterday we started looking at trinomials that have a leading coefficient other than 1. We looked at some examples that had common factors. Today we're going to look at examples of trinomials that don't have a common factor and see how we can factor them. So just to quickly refresh your memory, here's an example problem we did yesterday. All three of these terms divided by 4, so we factored out the 4. And in the parentheses, I put what was left after I divided each of these by 4. Then I factored this trinomial to get this final factored answer. So that's what we've learned so far. Today we're going to be looking at trinomials like this, where the leading coefficient is not 1, so we can't just see what multiplies to this and adds to this, because we have another number here to think about. But looking at all three of these terms, there's not one number or one variable that divides into all three of these. So I can't just factor out a number right away like we did yesterday. So instead, what we are going to use is called the AC method. So in your notes, you should have these with some blanks, so you can fill in the blanks as I go through the steps. So these are the steps that we follow when we have a trinomial like this, with a number other than 1 being multiplied by the x squared. So the first step is to list the factor pairs of AC, then determine which factor pairs of AC has a sum of B, so such as M and P. So what that means is we're multiplying this 2 times 4, for example, in this problem here. This is A, B, C, so we're multiplying A times C. And we want to see what numbers multiply to this product and add to this B, this 9 here. I'll go through this in more detail later. Then we're going to use the M and P to rewrite the trinomial as a 4-term polynomial. You can also add this into your notes. It will look like this. So we took the original B and we're splitting it up into M and P. We're figuring out what these two numbers are. And then lastly is to factor by grouping. I know just seeing the steps it might be a little confusing, so I'm going to go through it with this example now. Okay, so to walk us through the steps with this problem, the first step is to list the factor pairs of A, C. So when we have A and C right next to each other, it means multiplication. So I'm going to multiply the A and the C. Here is the A, the 2, and the C is the 4. If you're ever not sure of what letter goes where, on the notes I have an example of the general formula with the A, B, and C. So the first one with the x squared is A, and then the last one, the number by itself, is C. So I'm going to first multiply them together, and AC equals 2 times 4 is 8. So what I'm going to be doing is looking now on step 1, list the factor pairs of AC. So I'm going to be thinking of what numbers multiply to equal 8, and then step 2, determine which factor pairs of AC has a sum of B. So I'm thinking of what numbers multiply to equal 8 and add to equal 9. So thinking of the numbers that multiply to 8, 1 times 8, that equals 8. So I'm going to check to see if I add those, will it equal this 9? 1 plus 8, yeah, that equals 9. So I know that the two numbers I'm going to use are 1 and 8. And then step 3, I will use the M and P to rewrite the trinomial as a 4-term polynomial. So instead of 9, I can break this apart into 1 plus 8. So I'm going to rewrite the trinomial, 2x squared, but now instead of 9x, I'm going to split it up into 1x plus 8x, and then plus 4. And then lastly, step 4 is to factor by grouping. So I'm going to factor this first group here, and then the second group. So I will take out what's in common in each group. And then I see we have this Oops, I forgot the 2 there. I see we have this parentheses in common, so I can factor that out. And then I'd be left with this x and this plus 4. So this here is the final answer. This really is the same as what we were doing before when we were factoring. It's just that instead of another number, we had a 1 here. So it's like we were actually multiplying the a times the c, 1 times whatever. It just didn't change the c since it was multiplying by a 1. So we multiplied these two together to get this, and we see what multiplies to this and adds to the middle term with the x, like normal, and then factor until it's completely factored. So if you're curious on why this works, it's kind of a long explanation, so I don't want to take too much time to explain it right now, but I think it's really interesting and really cool. I found a good tutorial explanation of this on YouTube. I'll put it in the description box down below. So if you're curious on learning why this method works, check out that video to see the explanation. Okay, so if you're still not feeling totally confident on how we do these steps, I'm going to do another one with you. But if you're feeling good about it, go ahead and get these 6 problems done on the page. I am checking these problems again, so make sure you get all the problems done on this notes page. Okay, so anyway, going through this one, 2x squared plus 5x plus 2. The first step is to multiply the a times the c. So in this case, the a is 2 and the c is also 2, so I'm going to multiply 2 times 2 to get 4. Now I'm going to think of numbers that multiply to get 4 and add to get 5. So I'll start off with 1 times 4, that equals 4. Now I'm going to check 1 plus 4, does that equal 5? Yes, it does. So I know that the 2 numbers I'm going to use are 1 and 4. So I'm going to rewrite it now, but instead of 5x, I'm going to put 1x plus 4x. Now I will factor this by grouping. In common we have an x, and here we have a 2 in common. All right, I'm noticing this parentheses is in common, so I can factor that out. And then I'm left with the x and a plus 2. So here is the final factored answer on that one. This problem here, it's not a problem on your page, but it's just a random example I'm giving to show you one more possible answer that you could get. So going through the work on this one, again, first I'm going to find AC. So I multiply 2 times 1 equals 2. Now I need to look for numbers that multiply to 2 and add to 5. So numbers that multiply to 2, 1 times 2. All right, that equals 2. If I add them, 1 plus 2, that equals 3. But we're looking for 5. And there's no other numbers that multiply to equal 2, only 1 times 2. So if you get a situation like this, where you've checked all the possible numbers that multiply to this, and none of them add to get your B, then this is a special situation. It's called a prime polynomial. Maybe you've heard of a prime number before. It can only be divided by 1 in itself. It's the same idea. This polynomial cannot be divided by anything else. So we can't go backwards to the multiplication problem. We can't divide it by anything, so it's prime. So on the rest of the problems, if you get any numbers that multiply to AC but don't add to B, then you can just say it's a prime polynomial. All right, so here are the other 5 problems on the page that you need to complete in addition to the 4 on Google Classroom. Just final notes on this. So some of them might be prime. Be sure you check for that. And also be sure you're still thinking about what we learned yesterday. Before you solve it, check to see, is there a number that all 3 of these can be divided by? If they can, then go ahead and first divide that out. If they can't, then use the AC method. So there is at least one problem here, actually a couple, that we can factor like what we did yesterday. They have a common factor in all three terms. So be sure you're thinking about that as well. You can pause the video when you're done. I'll show the answers. That way you can check your work. All right, so these are the answers that you should have. I didn't put my work on here since there wasn't a ton of space. So if there's anything you're not sure on how I got my answer, please ask me and I'm happy to help. A couple things I wanted to point out. Notice how this problem is a prime polynomial. 2 times 6 is negative 12. Nothing multiplies to negative 12 and adds to positive 3. So this one cannot be factored. The last two problems, all three terms had a common factor. So our first step was to factor that out. And then with whatever was left, we continued to factor it until it was completely factored like that. So again, if you have any other questions, please let me know. I went through this, I explained it kind of quickly, so I'm happy to answer whatever questions you have.